So in problems 105 and 106, we have a structure with three different members that are all pinned together. And so we have lots of points in our system that we need to identify. So I use G as my origin, and then I have points A, B, C, D, E, F, and H relative to point G. And so we can see that at G, D, B, and E, we have general reaction forces that have two components, one in the X and one in the Y each. So that gives us 8 unknowns. And then at H, we have a roller and so that the horizontal force at H has to be 0. So we only have a vertical force at H. So that gives us 9 unknowns. And we needed to get 9 equations to be able to solve for those. We have two external loads acting in the horizontal direction. In problem 106, we're just asked to set this one to 0. So again, force and moment balances, and we need to do on three different substructures or the whole structure together. So I looked at the whole structure together. So that involves forces at G, H, C, and F. So those are the two external loads and the constraint reactions. So that'll give us 3 equations from these. And then I looked at member DBC, and that is the member DBC. Yeah, so that's the upper L upper angle L-like bracket. And so this is an external load, and these are internal loads. And then I looked at member BEH, and so we had to make sure that the internal load acting on BDE is minus the external load acting on, or the internal load acting on BEH. So we need to make sure we have a minus sign in front of FB in our equations. So whenever we'd have a B here, we'd have a minus sign, and same with here for this set of equations. And so E, we haven't used before, so again, I'll just say that that's plus. And then H is an external load. Oh no, H is a reaction force. So what we need to make sure is that all these internal loads, whenever we use them, we have both plus and minus. And it doesn't really matter if we use minus here and plus here or the other way. It just tells which direction we're looking at. And if we're looking for the force on a particular member, we got to be sure which way we're looking, which one we're looking at, because the force is equal and opposite on the two members. So in the end, we get 3, 6, 9 equations, and we have 9 unknowns, and we can crank through the algebra. And the first case we get, FB is 10 kilonewtons in the horizontal direction and 13.75 kilonewtons in the vertical direction. And at D we have minus 22 kilonewtons in the horizontal direction and minus 13.75 kilonewtons in the vertical direction. And so one check we can do is that if we look at member let's see here, DBC, we know that B and D, the vertical components, should cancel out. So that makes sure that these are equal and opposite, because there's no external vertical load acting on that. And so we can see that these two should, this minus this, minus this plus this, well, these should counteract the, so we get minus 12 here total, so those counteract the external load acting on it. So that's some checks we can do to make sure that that answer seems reasonable. Again, on DAB, we have, this makes sense that this is negative, these are negative. Okay, so it's acting in this direction on that. On GDEF, it would be acting in the opposite direction. And so in problem 106, we're asked to basically set the force at F to 0, and we can do that, and we can just basically crank through the algebra again. And so instead of having an F here, we get rid of that guy. And so then we'll get 9 equations and 9 unknowns again. And we can crank through that algebra. And we get that FB is now 8 and 12.5, and FD has components minus 20 and minus 12.5. Again, makes sense that these cancel out. These things should add up to counteract the 12 kilonewton load, which they still do. And again, they're in the same direction as we'd probably expect. And these are a little bit, these are smaller because we're removing some load from the structure.